We'll proceed in pseudo calculus problems. Okay, mind-blowing discussion we are progressing in pseudo calculus problem. So in pseudo calculus problem, what problem we have taken, and it is brainstorming, and that problem is how to calculate the average length. This is also called expectation or mean. How to calculate the average length of a stick? What is actually I broken it. Right now it was one stick. Right now it was one stick. Okay, I broke it. So up, where what it is there? Okay, there is a stick like this. There is a stick like this, and this stick, this stick, I am going to break into two parts. This stick, I am going to break into two parts, and then I broke it. Now it is in two parts. So this is the smaller one, and this is the larger one, or of lengthier one. This is had more length than this. Okay, together. Okay, if this is the stick, then together it is 1 meter long. Consider 1 unit long. I don't know it is 1 meter or not. Call it 1 meter long. Now randomly I break into two parts, and if I break into two parts, then this is the smaller part and this is the larger part, bigger part. If this is the scenario that this is the bigger part and this is the larger part, I'm sorry, if this is the bigger part and this is the smaller part, some smaller part I just throw it, and the larger part I keep it. Okay, see exactly the same length. What the length I'm showing now. Up. How to bring it back? Okay. Okay, this is the stick back. Like this, I have so many sticks of 1 unit length. There are n number of sticks that I have. So many. N means infinite. So many. I get one, break into two parts, and a smaller one I throw it, and larger one I keep it. Okay, in that fashion, if I have a stick, okay, if I have a stick of unit length, and then potentially I can break into two parts from any location. Up. Okay, now this is the stick. Now how I can break a stick like this? I can break this stick. This is not the midway. I was thinking so. Midway is somewhere here. Now I can break this stick after the midway. I can break this stick before the midway. I can break this stick at the midway. If I break this stick at the midway, then any part I can retain. If I break this stick after the midway, then this is the larger part that I have to retain. If I break this stick before the midway, then this is the larger part that I have to retain now. All the larger part, when I break a 1 unit length of a stick into two parts, and breaking point is either before the half or after the half, at the half also. If I break at the half, any side I can take, and then I am keeping it at one place. And then when all the infinite sticks breaking is over, and then I go and start counting or start measuring the length of the largest part. And then when I measure the length, consider that they are alpha in numbers. They are alpha in numbers. If they are alpha in numbers, then I calculate the total length. Consider total length that come is L. Okay, number one, number two, number three, number four, all the broken part, but the larger one. And then I collect, then I start measuring the length. When I'm done with the measuring the length, one length, write it. Then next one length, write it. Add all the length, divide by alpha because there are alpha number. Okay, consider all the length. If I add, it becomes capital L. Capital L by alpha is how much? That is a question mark. Capital alpha by capital L by alpha is how much? What is the mean or average length of the larger part I get when I break a stick into two parts? If I break a stick into two parts, there will be a larger part and there will be a smaller part. If I collect while breaking alpha number of sticks of unit length, then what is the average? What is the average length of the stick? Okay, what is the minimum length of the stick in the larger side? That I can see that is the half of the stick. That is the minimum length I see. What is the maximum length I see? Theoretically, the full stick. I broke in a fashion that it did not get break. At the end only I broke. Means full stick to the lowest size in the pool is the half of the stick, whereas the highest side, largest side is the full of the stick. What is the average size of the stick that we see? Anyone would say low is half and highest is full. Means more likely it will be 3 by 4. It looks like that. Anyway, we have to calculate the average length of the stick that we get. Anyway, what we did with this? Consider this is the largest one. Up, 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 up. Okay, so what is the fundamental now? Fundamental here is that how to calculate the average length of the stick that is collected, the larger stick that we get after breaking the stick, the larger stick we collect, and what is the average length of the larger stick. Okay, to calculate that we have to find the how to find the average length. Okay, we have given a very big example, good example. What is called average? What is called average? To calculate the average, what is called average? To calculate the average, like we have a given example that a class has 10 students. Class has 10 students and 10 students now they are now appearing in examination and they are securing marks. Okay, when I am seeing the marks, I am trying to find out what is the average marks now. Out of the 10 students, what is the average marks now? I have to add all the marks and divide it by 10. That is called average mark. If I want what is the average length of the largest section, then I have to add all the length of all the largest section and then divide by the number of sticks that we are counting upon. Okay, that is the fashion. Then what is the average mark a student is getting when there are 10 students appear for the examination? Now, as we have given this example earlier also, then two students are getting 40 marks. One is 3, 4 are getting 50 marks, 3 are getting 60 marks, and one is getting 70 marks. Now, I am just adding all the marks 40, 40, 40, 6, 50, 50, 50, 50, 60, 60, 60, and 70. Add it and divide by 10. Okay, whatever you get, that is the average mark. Is there any other way to calculate it? Okay, we can calculate it through graphical way also. What is your graphical way? Now consider that this is the marks. This is the marks axis. This is the marks axis, and this is number of a student. This is the marks axis, and this is number of a student. Makes sense? Now, in that fashion, if it is 50, the number of students are 4. If I draw a bar, its height will be 4. At 40, height will be 2. At 60, height will be 3. And at 70, height will be 1. What is the total? What is the total marks obtained by the students? This is the idea. Divide by number of students. What is the total marks obtained by the student? Now, if I take 40 marks, then what is 40? From the origin, if this axis is for marks, from origin, this is the axis for the mark. If 0, comma 0, then at 40, at distance 40, I have height 2. I have height 2. Then I have to multiply this height 2 with the x-axis. If this is x, then this is function over x. Makes sense? Okay, if I say I have one axis like this and one axis like that, there is a high chance that this vertical axis, whatever data we are placing in, that will be function over x. A different x, it would change. It is not independent. In that fashion, then we say that x into fx plus another x into fx plus another x into fx plus another x into fx. What x fx you are talking about? Okay, just write it down. Okay, x1 into fx at x equal to x1 plus x2 into fx at x equal to x2 plus x3 like that. What is your x1? 40. And what is fx1? The height 2. 40 into 2 plus 50, that is the x, into 4, that is the height, plus 60 into 3 plus 70 into 1. Just add it, divide by the number. No, 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 I don't want to divide by the number. Just tell me what is x fx, and that should be the result. Okay, that you want. Okay. Now earlier the height was number of the students. Now think that number of students right now. It will this now what is the height now? That is the number of students. It is also called density. At any particular marks, what is the density? What is your density? Density. Consider a stick, and it is not the smoothly smoothly distributed stick. Somewhere stick is highly dense. Consider this is not a wood. Consider there is a metal stick, and metal stick somewhere there is a gold, somewhere silver. Archimedes fundamental, somewhere gold, somewhere silver, and somewhere it is iron, somewhere aluminium. Wherever there is a aluminium, that portion will be lightweight, and where there is iron, that portion will be heavy. Like that, every places portion will have different weight. What do you mean? I mean that it depends upon what is the density of the material. If density of the material is very high, then at that point weight will be high. What is your net weight? What is your net weight? Then let's see what is your net weight. Consider that the vertical bar, if I take this axis, simple, I take this axis, then every moment there is a density graph. What is the density at one particular time? So at iron, density will be high. Means at this moment, when it is iron, consider that x equal to 1 is for silver, x equal to 2 for iron, x equal to 3 for gold, x equal to 4 for aluminium. When x equal to 2, that is for iron, the density height will be very high. It is highly dense. At this moment, it is highly dense. If we are in phase of calculating the weight, then this portion where iron is there, I have to multiply this distance. Makes sense? Okay, the density what we are talking right now, that is the density that talks about the per unit length. Though marks we are talking, that is not per unit length. Okay, so here density is per unit length. We will see. So if I have iron and its length is 1 here and density is 10, 10 into 1 is the weight. If length is 1 for the gold and density is 5, then 5 into 1 is the weight of the gold. Means height what we see is the density. Similarly, if we are drawing a graph where this is marks and this is the number of a student. Number of a student, it adds as a density. If I multiply this number of a student, that is the density with the x-axis. So here, this is origin and this is x-axis. If I multiply this x-axis with function over x, that is the density. Okay, density into x will give the real number, real weight. Okay, so density is density is 4 and this length is 50. Means the weight of that marks 50 marks is actually 200. Okay, because for a student they have secured 200. The net weight of 50 marks is 200. Net weight of 40 marks is 40 into 2. Net weight of 60 marks is 60 into 3. Net weight of 70 marks is 70 into 1. Calculate the net weight divide by the number and you get the average weight or average marks. Okay, what is other way? Rather than this density, let's measure it as a probability density, not the normal density, probability density. Out of 10 students, what is the probability density that the student have got 50 marks? Then it is 4 by 10. Out of 10, it is 4. So height is 4 by 10. At 40, height is 2 by 10. At 60, height is 3 by 10. At 70, height is 1 by 10. Now we will add x into fx. So now the net average mass that is calculated is summation I equal to 1 to n. Summation I equal to 1 to n x fx. Xi fxi or fx at x equal to xi. Make sense? So now summation of I equal to 1 to n is 4 here. And then xi, x and subscript as I, x bottom right as I, function over x bottom right I, fxi or fx at x equal to y. If I sum it n time or 4 times, I get the average mark. Okay, what it is? Now it is 40 into 2 by 10 plus 50 into 4 by 10 plus 60 into 3 by 10 plus 70 into 1 by 10. Just add it, sum it, you get the average marks of the student. Makes sense? Okay, in that fashion, we are trying to calculate the average length of the stick. If I break a stick in two parts, then larger part if I keep at one place, what is the length of the larger part? That is under question mark. Then it can be solved through digital way in discrete manner, and it can be solved through analog way or continuous manner. Okay, what is discrete manner? What is continuous manner? Discrete manner, if we are talking, then the stick, now this stick I am going to make in two parts. This stick, consider it is of unit length. Okay, I am not taking another stick. Consider this is the stick that I want to break it. I want to break it. And this stick is of unit length. Now let's divide into n part. This we have already talked. Let's divide into n part. If I divide into n part, then we have part number 1. This is the part number 1, part number 2, part number 3, part number 4, part number n. Okay, if that is the case, then what is the probability that I am going into to cut into ith part? First part, second part, third part, ith part. What is the probability that I am going to cut into a particular ith part? Any part if I am going to cut in any of the section I am going to cut, that probability is same. There is no biasing here. Then what it is? There are n sections. Probability to cut in any particular section is 1 by n. Makes sense? Since it is uniform. Same as if I roll a dice and then it can be 1 to 6, probability to get any number is 1 by 6. If there are n sections and probability to cut in particular section is 1 by n, discrete part proof is not available in any of the book. Analog part is available, but this one is not available. That's why we are giving big emphasis. What are we talking? We are talking how to come to integral calculus. How to come to integral calculus from repeated summation. That is the concept that we are pursuing. From multiplication, we have seen we can come to integral calculus. From division, we have seen we can come to differential calculus. From repeated addition, how we can come to integral calculus. This is priceless. This is $1 trillion. No one is writing this in the book. They just sum it and bring it to integral calculus. How we can bring it to integral calculus? As I said, this is $1 trillion expense. It's not available in any of the book. That's why it is priceless. Now, how we can come? Now, the idea is that what is the probability of cutting in any particular section? That is 1 by n. Now, I can draw a bar whose probability density is 1 by n because everywhere probability is same. Like in mark section, what is the probability that a student would get 50 marks? There are two ways to see it. What is a out of 10 students, if I fetch a particular student, what is the probability that he have fetched 50 marks? That is 4 by 10. Okay, so if this is the marks axis, then if I say 50, then the probability density height, that is 4 by 10. Okay, this is digital. Generally, it is called mass function. What is fx? We are saying function over x, and that is the height. Generally, it is this digital world. It is called mass function. If it is called mass function, anyway. Now we are calculating what is the mass function for any section. 1 by n. 1 by n into length from the origin will give the will give the actual will give the actual length. Makes sense? The marks and density marks and density will give the actual marks of the that if this marks is 50 and multiply by density, how much the weight of 50 is. Okay, similarly, if this is the distance, I cut at this is the length of the stick, and I cut in the ith section. So suppose ith section is here. Ith section, first section, second section, n section. Ith section is here. What is the number of sticks that I cut at ith section? Makes sense? How many sticks I can see they are cut at any ith section? That is the distance I into the density. Makes sense? Density is 1 by n and distance is ith section. Ith section, not that is the distance. What is distance? I into 1 by n. Okay, if I is n, the distance is full 1. Ith section distance is I by n into the mass function or density. If I multiply, I get the sticks. I get the length, all the sticks length that is cut at this point. The weight of the stick. What is weight of the stick? Weight of the stick means this length into number of a stick. Makes sense? Okay, difficult. What is difficult here? I consider I have alpha number of stick, that broken stick. I have alpha number of unit length stick, and I broke it at any part of the stick, and larger part I kept it. Now in the larger part, when I keep it, now then I'm trying to see in the ith section, whatever distance is come. Now I am going to add length of all the sticks that I have kept it. Stick number 1, that is the broken one. What is the length? Measure it. Stick number 2, what is the length? Measure it. Now there is certain that there will be of n type of length in the stick, because we have broken into n part, and someone has to break only in one of the area in the one part. Means all the stick, they are of n types only. The broken stick, their length is of n types only. Either one, this much, or this much, holding the second part, third part, fourth part. N part means the full stick. So all the stick, if I see, they are of length of size of n types only. They are not infinite length sticks, n types only. How many sticks are there whose length is I? Makes sense? That is their weight. Means total stick length, if I count, then stick, consider I sort it. Whenever I see the sticks, then I sort it. Sort with the lower to higher. Now the sticks which are of same size in the lower section, add all the length of them. This is the weight of that side stick. Makes it. Consider they are 10 in number. Again, I am saying same thing. Consider the alpha count of the stick is 10, and lowest will be the half. Certainly. If I break into n part, the n by 2 will be the lower one. The n by 2 size is 2, and n by 2 plus 4 is 6, and n by 2 plus 6 is 2. 10 is over. I could break into only in three sizes. One is n by 2 plus 4, and n by 2 plus 6. N by 2 is 2, n by n by 2 plus 4 is 6, and other is 2, 10. what is the weight of n by 2? Then it is what is the, now if I'm going to measure the full length, then it will be n by 2 into 2 plus n by 2 plus 4 bracket into 6 plus n by 2 plus 6 bracket into 2. This is the net length I got adding all the broken sticks. Divide by 10. In that way, the stick which is n by 2, its weight is n by 2 into 2. The stick that length is n by 2 plus 4. Its weight is n by 2 plus 4 bracket into 6. I mean, there is a high likelihood that stick length is that much only. Or if I choose n by 2 plus 6 length, then its weight is n by 2 plus 6 bracket into 2. Divide by 10, that is the average length. Similarly, if I am trying to get the ith section, what is the weight? Then ith section length into the probability density, that is the actual weight. That is the number of a stick into that size. How many stick we have of length I, and if I that number of a stick into I, if I do, that is the weight of the stick in the when we make the net length calculation. Capital L is the net length. What is capital L? Is adding the length of all 10 sticks. That is the capital L. What is the weight of ith section? Makes sense. Ith section, if I pick all the sticks whose length is ith section, that is I into 1 by n, I by n. The length of that stick is I by n. If I multiply by number of sticks that is of length I by n, I will get the how much is the weight of that stick length while calculating the capital L. So that is I into 1 by n, that will be the actual length. Ith section into 1 by n is the actual length into the probability density. That will give the net weight of this length in calculation of capital L or total length. Okay, now that plus everything. Now I is in two parts. Ith section I can break in before the middle or I can break after the middle. If I break after the middle, then I have to take this length and then density. If I break before the middle, then I have to take this length, not this length. From the origin, I don't need. I need the bigger length I take. I have to take this length and then the probability density. That will be its weight. So it looks like that I have two kind of summation now. One is I equal to 1 to n by 2, because I'm saying that if I break half of the chance I break before it and half of the chance I break after it. Okay, in that sense, summation of I equal to 1 to n by 2. Okay, I'm sorry, half of the chance. Okay, I'll rephrase it. Okay, just right now, there are two area in the breaking it. One area is the ith section I am breaking, it is prior to the middle, and ith section I am breaking, it is after the middle. If it is prior to the middle, then I have to take this length. This length is I by n. Then this length is 1 minus I by n into the height into 1 by n. Okay, the net weight of the stick in calculation of total length, if I cut prior to middle, is 1 minus I by n into 1 by n. Okay, now if I cut after the middle, then this section I have to take complete I by n into 1 by n. Now there are two scenarios. If the I by n, that is the total length, if I by n is less than n by 2, then net weight of all the stick, what we are doing is summation. We have to add all what we have done. Summation, if it is prior to this, summation I equal to 1 to n, I'm sorry, I equal to 1 to how many we have cut it, not 1 to n. I equal to how many we have cut it. I equal to 1 to how many cut we are making, maximum alpha cut we are making, because sticks, number of sticks are alpha only. Now we have, if I is prior to the middle, then it is 1 minus I by n into 1 by n. Then I is summation I equal to 1 to say alpha plus, and then we are saying If I cut I after the middle, then in that sense I by n into 1 by n. I by n is the length from the origin and 1 by n is the probability density. Summation I equal to 1 to alpha number of sticks. I equal to 1 to alpha, and then I equal to 1 to alpha, and then I by n into 1 by n. Let's settle it down. So it becomes summation I equal to 1 to alpha, and then 1 minus I by n bracket 1 by n if the cut is prior to the middle. Okay, if cut is after the middle, then I equal to 1 to alpha I by n into 1 by n. This is the kind of average length. How you say average length? Because the probability I have taken, the density is full probability. Full probability means 1 by n I have taken. The way we took in the student section, 4 by 10, not 4, 4 by 10. If I multiply 4 by 10 with the length and then add all, it will give the average. So here also it will give the average. Okay, so this is the summation. We have taken example. Like let's consider we divide into 16 parts. Okay, this is a tough example. Let's say we divide into 16 parts. If I divide into 16 parts, then what is the average mean of the section? Consider that I have divided I when I am dividing into 16 parts, then it is after the middle. If it is after the middle, then it will be summation I equal to alpha. Number of sticks are there. I equal to alpha. Hope, we will see. Anyway, summation I equal to 1 to whatever it is. That's why we are taking example. Summation of I equal to 1 to whatever it is. I by n into 1 by n. Now let's start adding it. Now for the, if it is half, then we have divided to 16 sections. In that sense, first section to 8th section will be before the half. 9th section to 16th section will be after the half. Then it is 9th section, 10th section, 11th, 12th, 13th, 14th, 15th, 16th, 8, 9, 10, 11, 3, 12, 13, 14, 3, 6, 15 and 16. 8 parts are, if I divide into 16 parts, 8 parts are after the half and 8 parts are before the half. Now for after the half, what is the weight of 9th section? What is the weight of the 9th section? If I calculate the weight of the 9th section, what is the distance from here and what is the probability density? Distance from here is 9 by 16. 9 by 16 and probability is 1 by n. Then 1 by 16. 9 by 256. That is the weight there. 9 by 256. Like what is the weight of a student getting 60 marks? 60 into 3 by 10. Like here the distance is ith section, 9th section, where it is divided into 16 parts. 9 by 16 is the length. And then 1 by n, 1 by 16, that is the probability of one section. 9 by 256, I believe 16 into 16 is 256. 9 by 256. What is the weight for the another section? That is 9 to, it is 8th to 9th, 9 to 10th. That is, we say it 10th part. Okay, like that we have to sum it. How many times we have to sum it? 8 times only. Means summation is I equal to 1 to n by 2, not alpha. I'm sorry about it. So we will rewrite it. Now the net average is summation I equal to 1 to n by 2, 1 minus I by n bracket into 1 by n. If I by n, or the cut is prior to the middle. Okay, if cut is after the middle, then it is I equal to 1 to n by 2, I by n into 1 by n. Since these two are mutually exclusive, they are not overlapping each other, and we want both the result, I have to add it. Makes sense? Simple. So it will be like this section and this section. If you add it, we get the mean length. Okay. Now what about the first section calculation? 1 minus I by n. If I cut in the first part, 1 minus 1 by 16, that will come as 15. So 15 by 16 into 1 by 16, that is 15 by 256. 15 by 256. Next will be 14 by 256. Next will be 13 by 256. At the end, it will be the eighth part. 1 minus 8 by 16. That will come as 8. 8. 8 by 6, 256. Net will be 15. 15 plus 14 plus 13 plus 12 plus 11 plus 10 plus 9 plus 8 divide by 256 plus, and another one is n equal to 1 to n by 2, that is 8, 1 to 8, and I, okay, I equal to 1. I'm sorry, here it is not I equal to 1. Here I is equal to 9. 9 to 16. So I'll again rephrase it. That's why we take example. So first section will turn into I equal to 1 to n by 2, because first part we are doing. First 8 section we are calculating. I equal to 1 to n by 2. 1 minus I by n. This is not available in any of the books, so I cannot write it anywhere or mug up. So it is not there. So summation I equal to 1 to n by 2. 1 minus I by n, that will be this side distance. If this is I, then we have to take other side distance. 1 minus I by n into 1 by n, plus, this is for first section, other section, plus for rest of the slots, plus I equal to n by 2, n by 2 plus 1. I equal to n by 2 plus 1 till n. I by n into 1 by n. The first one is 15 by 256 plus 14 by 256 up to 8. 15 plus 14 plus 13 up to 8 by 256. Another is I is from 9. So 9 by 256 plus 10 by 256 up to 16 by 256. Okay, if I calculate and add it, then we get the result. Here we have only, here everything is in common. 8 by 256 is separate here, and 16 by 256 is separate there. Otherwise, all are common, only 6 are common. That is 15 to 9 are common. 9, 10, 11, 12, 13, 14, and 50. 7 are same. Okay, what is 9 plus 10? 9 plus 10, 90, plus 11, 20, plus 12, 32, plus 13, 45, plus 14, 59, plus 50, that will come as 74. This came as 74 into 2, that will come as, I believe, 148. 74 into 2 is 148, plus 8, that will come as 156, plus 16, that will come as 172. 172 by 246, I believe this is what 256, this is what we are getting. We'll try again. 9 plus 10 plus 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. I have to add it. Then it will be 9 plus 10, 19, plus 11, 30, 30, and then plus 12, 42, plus 13 is 56, 55, plus 14 as 69. Okay, plus 15, 84. Actually, it is 84. 84 into 2 will be 168. 168 plus 8 will be 176. Plus 16 will go as 192. I believe more or less it is all right. 192. 192 by 256 is how much? 192 by 256. I believe someone has to calculate. 256 is 4 multiple of 32, I believe so. Okay, 64 into 6, 64, 16 into 16 is 246. That will come as 64 into 4 is 256. Here we have 192. That will come as 64 into 3, more or less. Oh, it is exactly. It is 3 by 4. The result is 3 by 4. In the past video, If I divide into 4 section, 8 section, we have already calculated. It also came as 3 by 4 only. Means the average length of the larger stick is 3 by 4. Now calculation going on how we can convert into analog continuous. Now consider n is tends to infinity, the number of sections. Anyway, what we have got, I'll summarize it. It is summation I equal to 1 to n by 2, 1 minus I by n bracket into 1 by n, because this is not available in the book. Plus this is for the n by 2 sections here. Another n by 2 plus summation I equal to n by 2 plus 1 to n I by n into 1 by n. This is 3 by 4. We have taken example, but there is no solid proof that it will be 3 by 4 only. Anyway, now we will see the continuous mode. So in continuous mode, if we are calculating, then how we can do? What is the discrete manner and how we can convert discrete manner to the continuous manner? Take one example, that is summation sign, and then it is I by n into 1 by n. I by, consider that from origin we are taking any distance as x. Now we are calculating the continuous way. And now the vertical bar, what we have seen, 1 by n, 1 by n, 1 by n, we combine all and it will become a vertical flat line, 1 by n. Is it the continuous mode? If we see the continuous mode from the discrete mode, how we can convert into continuous mode? Rather than dividing into n section, consider we are taking any x here from the x-axis, and at this x, what is the probability density? At any x, if I say that it's so smooth, then if I see the probability density at any point x, then it will be a smooth curve where the height is function over x. Okay, in that fashion, what is the mean? Mean is x into fx, x into fx, but I don't want x into fx. I know it is x into fx, but I want in integral calculus where it will be dx there. Okay, x into fx I know, into dx should be there, then only integration will happen. Okay, how I can introduce dx? We have seen that to introduce dx, we should have delta x. Okay, now I have to calculate fx in such a manner. I have to give the, what is the equation of fx, function over x. That is also called probability density into continuous manner. We cannot convert directly the digital to integral calculus, because there is nothing called continuity. If there is a discrete, then there should be delta there. Delta will convert into dx. Okay, okay. Well, now we are entitled to bring delta x now. Please watch our 3-4 videos prior. How to convert a repeated summation into integral calculus. If I talk repeated summation, okay, now let's consider that we divide into n part only. Let's consider I divide into n part where n tends to infinity. It is very small chopping I am making. Now, if I say up to any ith section, distance is x, consider, then height is fx. If height is fx, then what is the idea we are trying to calculate? We are trying to calculate mean through calculating the integration. This is for sure. I'll do integration for something. What is for something? I'll do integration anyway. Let's divide into n part again, and where n tends to infinity. Ith section, consider the distance is x. Okay, now if I multiply x with the fx, I get the average, I get the net weight. If this is the density, then net weight at this moment. If I add all the weight, will I get the net weight? No. Consider that there are students they have got marks. Students they have got marks. I believe it is all right. Students they have got marks, and they have got marks in one only. There is no real number, only in integer. Marks in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 100. So if I take x-axis as the mark section, then I have to divide x-axis only into 100 part. Then only we have x into fx plus x into fx. Consider I divide this x-axis into 10,000 part. Then every moment I can estimate what is the fx. Then fx into x plus fx into x will give me the average? Not, because it will be too many. I want maximum 100 in count only because it is 100 marks. Similarly, it is of unit length. Unit length, if I divide into n section where n tends to infinity, and everywhere if I multiply x with the fx, add it plus x in. There are so many now. It has to be only one actually. If it is unit length, it should be only one, not even n part. If I divide into n part and if I say x and fx, then what we are, if I suppose I write x fx dx, x fx dx, what is fx dx? If I take out x, it is fx dx. Fx dx means fx into delta x. If I break this integration fx dx into repeated summation, then it is I equal to 1 to n, number of chop we have made, fx delta xi. Okay, means whatever height we are taking at any moment, I have to multiply with the width. If I chop into n part where n tends to infinity, in that sense, one section will be very small. If I take height, then I have to normalize it with the width also, multiplying with the width also. In that fashion, it will be not the area. What is the integral calculus? Integral calculus is measuring the area. If I am saying fx dx, if I am saying fx dx, actually I am trying to calculate the area, that there is a graph called fx. This is x-axis. There is a graph called fx. This fx, if I do fx dx, I am trying to calculate the area underneath it. That is fx into fx dx. If I have fx at any moment and if I multiply with the smaller section, consider I divide this section into n number of parts, n tends to infinity. Each part is very small, very minute, because n is tends to infinity. If I do fx, fx, then if I multiply with the smaller part, it will give me the area of that section. Or I would rather say, to calculate what is the net area underneath it. If this is the fx, what is the net area underneath it? That is fx dx. That is the integral calculus. Fx dx integral calculus talk about the area that fx function makes with the x-axis. Now chop that area rather than chopping x-axis. Chop this full full curve into n part. See what is the area of a particular part. That is the fx into delta x. Fx into delta of the one section. One section is so small that fx into delta x will become very small. That is the area of one chopped section. If I add all those area, then I get fx dx. Similarly, if I am trying to calculate average mean where we are talking about x and fx, if I multiply this fx with delta x, fx with delta x, then I get the one area. If I add all, then I can write into integral calculus as x fx dx. The question is arising, what is your fx? Okay, what is your fx? That if you multiply fx with dx, it will give you one area. If you add all, it will be the full area. That is under question mark. So I believe it is all right. Probably in one more session I'll describe it. If I'm trying to calculate this mean add x into fx, this is what we are trying from the student marks also. X into fx. If I add all x into fx, where fx is the probability density, if I add all, I get the mean. But I want it through x into fx dx so that it will be smooth now. In that fashion, I have to, if in that fashion, the analogy, the description is that fx dx actually give the area underneath the fx. If I chop into n part, then one length is dx or delta x. If I multiply fx at that point into delta x, then fx at another point into delta x, fx at another point into delta x, that will give the area of each section. And if I add all those, it becomes fx dx. Okay, this proves that fx, if I chop it into so many parts, fx into dx should be same as what we calculated for the digital wave, that is 1 by n into 1 by n, 1 by n into similar to that. Okay, I don't know what is fx dx and whatever it is. Okay, how to get fx so that fx into dx will give the net area here, and if I add all the area I get the net result. Make sense? Okay, now if I say that our graph is fx and that is the probability density, if I multiply with the width, it should give the probability at that point. Make sense? Our concept is I want to achieve the mean through x into fx dx. That is the aim. X I know, okay, dx I understand. What will be fx? So that we will get the integration. Fx is not same as the digital one I had taken 1 by n. That is the problem. Then what I have to take? Fx. Okay, fx is called probability density. I know that much. For digital, it is 1 by n. For every section, it is 1 by n for digital. That is the probability density. For continuous, what will be fx? What you know? I know one thing. If I take probability density and if I multiply with the full length, it should be 1. Hope, 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 hope. Are you sure? Yes. If I add all the probability density, all, then it should be 1. Because net is 1. Are you sure? Yes. Like in students' marks, the student who got 40 probability density is 1 2 by 10. Student got 50 probability density is 4 by 10. For student who got 60 probability density is 3 by 10. For student who got 70 mark probability density is 1 by 10. If I add all the probability density, it should be it should be it should be 1. That is 2 by 10 plus 4 by 10 plus 3 by 10 plus 1 by 10. It should be 1. Similarly, if I have probability density as a continuous, not in a discrete manner, if I multiply all the continuous way with the area, full area, it should come as 1. That is the characteristic of probability. Then what is fx now? When it should come as 1, when it should come as 1 and this length is 1, then what we are trying to say? What means area? If I multiply fx over full x, then it should be 1. Means area underneath this fx for the full length should be 1. Fx dx integration from x is 0 to 1 should be 1. Make sense? That is the prerequisite of 1. If I have probability density not as a var, if I have a continuous wave, I can chop at any place and see what is the probability density. I can chop at any place and see what is the probability density. That will not be 1 by n that we see in digital world. What it will be now, that is the question mark. But one thing is for sure, that if this is the probability density, then net probability what we get, if I multiply height with the width, height with the width, height with the width, height with the width, then net what we get, it will be 1. That is for guarantee, because net probability is 1. If I add all the bar, it will be 1. In that sense, fx dx integration from 0 to x should be 1. Here x is 0 to 1. Fx dx should be 1. Where it is possible, when fx equal to 1. If fx equal to 1, then 1 dx is x. 0 to 1 is 1. Now it's possible. Means if I take fx as 1, there we took fx as 1 by n. Here we take fx as 1. So now if I say that if I want mean, then it should be integration sign x into fx dx, where fx is 1. Then it will solve the problem. Then how much it will be? If I cut x, if I take 0 to x, where x is 0 to 1, if I cut prior to it, then this distance is 1 minus x. If I cut after it, the distance is x. Means integration, if I am cutting before it, integration x is 0 to half. Integration x is 0 to half. It is 1 minus x fx dx plus integration is half to 1, then it is x fx dx, where fx is 1. Means integration 1 by 0 to half 1 minus x dx plus 1 by 2 to 1 by 2 to 1 x dx, it should give 3 by 4. Anyway, we will discuss more on it. This is mind blowing. This is how we transition from a digital world to calculus and this discrete world to calculus. If this fundamental is very clear, then anyone can tackle anyone. If you see in the book, directly it is written like this: 0 to 1 by 2 x fx dx plus 1 by 2 to 1, 0 to 1 by 2 1 minus x fx dx, 1 by 2 to 1 x fx dx. Okay, how it is, no one knows. How it is, no one knows. This is the point where people they leave mathematics. Yes, it is very difficult. We will talk more on it. Please do not mind supporting us. Plus 91 is the India country code, 9483160610 is the telephone number. Plus 91 is the India country code, 9483160610 is the telephone number.